Wednesday. I hope everyone is having a wonderful, chilly morning. We are moving on to our second day of learning for this week. And today what we're going to be looking at, as you can see on our schedule, increase the size, is volume and operations just like we were working on yesterday. But the big difference with our work today is that now we're going to be using multiplication just like we were yesterday, and now we're connecting volume, thinking about it as packing, and we're also thinking about volume as filling. So big news today. I wonder how many of you already know this. I remember that I was totally fascinated by this when I learned this for the first time. But if we were together in class, we would do an experiment that would prove this, but we're not, and we're being flexible. So I just want you to know something super cool about the metric system. That 1 cubic centimeter is equal to 1 milliliter. It's super cool. If we were to drop 1 cubic centimeter, do you see this could look like one of those centimeter cubes? If we were to drop that into a beaker, the water would increase, or the water would be displaced by 1 milliliter. So the conversion factor between 1 milliliter and a cubic centimeter is 1. They are equal to one another. 1 milliliter is a liquid volume, and cubic centimeters are physical volume, like a tangible volume. But because the metric system is so awesome, they're actually equal to one another. So we're going to be I definitely want you to click through here and check out these links, and definitely review this anchor chart and think about this, because we're going to be working on some problems where you're going to have to think about, this is something you'll do independently, but I'll do something like this here in just a moment. You're going to think about the volume of a prism, and then you're going to think about, if I filled this prism with water, how many milliliters could I fit in this prism? And we'll talk about the fact that, again, 1 milliliter is equal to 1 cubic centimeter. Again, if I were to drop a cubic centimeter into a beaker that had water into it, the water would be displaced, or the water level would increase by 1 milliliter, because these two represent the same volume. It's super cool. So we're going to take a look at some problems, and I think this will be a fun day. I think you all will be into this. So stay tuned. Okay, my buddies, we're going to take a look at this problem, and this is actually the only problem I'm going to do for our video today, because your independent work is really an exploration of what I'm going to unpack here and what I sort of already unpacked it in the introduction. Okay, so we are going to look at this prism as a tank. So it says the tank right here, shaped like a rectangular prism, is filled to the top with water. Okay, so let's just imagine that happening. Will the graduated cylinder hold all of the water in the tank? If yes, explain how much more will the beaker hold? If no, how much more will the tank hold than the beaker? Explain how you know. Very cool. Okay, so again, what we're doing in this lesson today is we're connecting volume. We've been talking about volume as like terms of packing, centimeter cubes, or any sort of cubes inside of an object. Now we're going to be connecting that with liquid measurement. And again, I want to bring this to the forefront of your brain and tell you this amazing fact that 1 cubic centimeter is equal to 1 milliliter. That is the beauty of the metric system. It's just such a beautiful thing. Nowhere in the English system is 1 square inch equal to 1 ounce. No way! Unfortunately, that does not happen. That is not a thing. But in the metric system, we have these beautiful relationships that just make so much sense. So I am thrilled that we get to investigate and kind of work with that today. So first thing that we need to do is figure out, what is the volume of this prism or fish tank? And we know that we can find the volume. You all worked on this a great deal on yesterday. Volume is equal to the length times the width times the height. volume has 3 components, so it's known as a cubic measurement. So our volume, we can find our volume by multiplying these 3 measurements, and again, because we're multiplying, it does not matter what order we multiply these measurements in. So we're looking at 8 times 10 times 13. I'm going to try to do as much of this in my head as I can. I know 8 times 10 is 80, and now we just need to look at 80 times 13. I'm going to just look at 8 times 13, and then I'm going to bring a 0 to the party just to make my life easier. And we can just use that space here to look at 13 times 8. 3 times 8 is 24. Thank you, Logan. And then we have 8 times 1 is 8, plus 2 is 10. So 13 times 8 is 104, but don't forget that we're bringing 1 0 to the party. So the volume of this cube is going to be 1,040 centimeters cubed. But don't forget that 1 cubic centimeter is equal to 1 milliliter. So the volume also is 10,040 milliliters. So if we were going to pack that tank with centimeter cubes, we would be able to fit 1,040 centimeter cubes. If we wanted to fill that tank with water, we would be able to fill that tank with 1,040 milliliters of water. So the graduated cylinder that's here, will it hold all the water in the tank? Let's think about that. This graduated cylinder, it looks like when it's filled to half, it will hold 500. And then when it's filled to the brim, it will hold 1,000 milliliters. We all know that 1,000 milliliters are equal to 1 liter. So if we were to fill this entire graduated cylinder all the way to the brim, it will hold 1,000 milliliters. Will the graduated cylinder hold all the water in the tank? Well, how much water will this tank hold? 10,040 milliliters. So the answer is, well, will the graduated, I'm confused. Are we pouring the graduated cylinder into the tank, or the tank into the cylinder is filled to the top with water? Will the graduated hold all the water in the tank? I'm nervous about pouring the tank into the cylinder, but we're just gonna deal with that. That's fine. No, the cylinder will not hold all the water in the tank. If yes, blah, blah, blah. If no, how much more will the tank hold than the beaker? Well, the tank holds 1,040 milliliters, and the beaker holds 1,000 milliliters. So it looks like if we were going to be really brave and we were going to pour somehow this tank into the cylinder, we're going to end up with 40 milliliters of water spilling all over the floor because the tank holds 1,040 milliliters and the cylinder only holds 1,000 milliliters. So I just really hope that you can focus or imagine this happening. Imagine like somehow picking this up and pouring it into the graduated cylinder and seeing that yes, this is going to hold a little bit more water than the beaker or the cylinder, so we are going to have a bit of a mess. So don't do it. Not a good idea. Have fun with this connecting this liquid volume with our physical volume. I think you're really going to enjoy it. Email me or Google chat me with any questions. I will see you, hopefully everyone, this morning for our Google Hangout, and keep up the great work. Bye, sloths.